Okay, so I was running out of recording ability in the last video. For this one, let's see, we still have to multiply our number of hydrogens by our atomic mass of hydrogen. So that's 12 times 1.00794. And I get 12.09528. And now it's time to add these two numbers up. And some people put all of this in the calculator at once, and feel free to do that. I'm just breaking it down for people who might have trouble with this content and with math in general. Okay, so I'm adding my 60.055 plus my 12.09528, and I get 72.15028. So that's grams per mole. I like to think of it as 72.15028 grams of pentane equals 1 mole of pentane. And so I would take this molar mass and I would put it back up here. Next, I'm going to do hexane. So that will be 6 times 12.011. I get 72.066. Now let's do hydrogen. That's 14 times 1.00794. And that is 14, or that what I get is 14.11116. And now I'm going to add these two numbers together. So that is 72.066 plus 14.11116, and I get 86.17716 grams per mole. Sorry it's so small here. But as I like to think of it, it's 86.17716 grams of hexane equals 1 mole of hexane. And that number we would take and put up here. But I have rewritten this part on the next piece of paper, or part of it. Okay, so we started out with a density of pentane and a volume of pentane, and we used that to get a mass of pentane. Now we need to take that mass of pentane and find the number of moles of pentane. So grams to moles here. So we had 22.05 grams of pentane, and then our molar mass is 72.15028 grams of pentane equals 1 mole of pentane. Similar deal, 36.3 grams of hexane, and we found 86.17716 grams of hexane equals 1 mole of hexane. So for this next part, I always recommend putting it in the calculator a certain way, and I do this, well, you're in Gen Chem 2 now, so you've already gotten over stoichiometry, but sometimes when we have long conversions that are several steps, it can get confusing on when to multiply and when to divide. So I've gotten into the habit of telling students to get into the habit, or suggesting they get into the habit, of putting it all in the calculator at once this way. Do an open parenthesis, then multiply everything in the numerator, and do a closed parenthesis, and then divide, and do an open parenthesis, multiply everything on the bottom, and do a closed parenthesis. And don't forget there's an understood 1 here if that bothers you, that it's not there. So I am going to put that into the calculator that way so we can find out how many moles of pentane and hexane we have. So let's see, open parenthesis, 22.05 times 1, close parenthesis, divide, open parenthesis, 1 times 72.15028, close parenthesis, enter. So for pentane, I get 0.305612196 moles of pentane. Now let's do hexane. So open parenthesis 36.3 times 1, close parenthesis, divide, open parenthesis, 1 times 86.17716, close parenthesis, enter. So I get 0.42122 52991 moles of hexane. I forgot to mention that grams in the numerator cancel with grams in the denominator. Same with hexane. You probably already know this if you're in Gen Chem 2 though. All right, so now we're ready for our mole fraction. So for pentane, that's going to be long numbers. Okay, so in the denominator, we'll add both of these. 0.3056121196 plus 0.42122529991. And then, since we're doing the mole fraction of pentane, we're going to put pentane in the numerator. And then for hexane, we're going to do a similar deal. So 0.305612196 plus, sorry, I ran out of room, so I'll put it down here, 0.42122529991. And then in the numerator here, we'll put our moles of hexane. I recommend, again, parentheses down here for our denominator. Similar deal as up here. All right, so mole fraction of pentane is going to be 0.305612196 divided by, open parenthesis, 0.305612196 plus 0.42122529991, close parenthesis. I get a mole fraction for pentane of 0.420468335. And then I'm going to put this one in the calculator. 0.42122529991 divided by, open parenthesis, 0.305612196 plus 0.42122529991, close parenthesis, equals. And I get 0.57953 16645. Now I'd like you to notice that if you stick this number and this number into the calculator and you add them, it should give you 1. So what that means is, if you wanted to, instead of calculating this number, this mole fraction of hexane, once you got your mole fraction of pentane, you could just say 1 minus my mole fraction of pentane. And if you stick that into your calculator, you'll see that it equals the mole fraction of hexane. But I didn't want to show that to you at first because conceptually it's less straightforward than this. Similar idea is this. You could have just taken this number and divided by this number, but in case there's any confusion anywhere, I wanted to go about it the proper route. Okay, so now we've got our mole fraction for pentane, our mole fraction for hexane, and we're ready for the, what's it called? Raoult's